Good morning, everyone. Thanks for joining our webinar today. My name is Mel Summers and I am the Marketing Manager for Climalife in the UK. So before I hand you over to Neil this morning, I'd just like to cover off a few housekeeping points. So first of all, a recording of the webinar will be available after today. It will be sent to everyone that's registered and will also be published on our Climalife YouTube channel as well as on our website. Secondly, as ever, we're reliant on the successful use of technology today. So if any issues do arise during the presentation, we will try to resolve them as quickly and as smoothly as we can. And if for any reason you do drop out of the session, you'll receive a recording afterwards. So don't worry, you won't miss anything. Throughout the presentation, Neil will be covering off some of the questions that you raised with us when you registered. Plus, hopefully there'll be some time at the end to take a few more. So if you'd like to raise a question this morning, you can use the control panel on the right-hand side of your screen. You'll see a speech bubble. You just click in there to open the question function and type your question in the box and then submit it. So we'll try to answer as many questions as we can today, but any that we don't answer will be followed up later. So now it's time to hand you across to our Senior Technical Sales Manager, Neil Roberts. Good morning, Neil.
Good morning, Mel. Thank you. Good morning, everyone. Well, Mel skipped over the agenda, so I'll just go back.
Sorry, Neil.
That's all right, no problem. Okay, so it's great to have everyone on the call. It's great to see so many people interested. And as Mel said, we'll try and incorporate some of the questions which you gave us when you were registering. The agenda is pretty simple, just 3 points, but it's a huge subject area, and we're really only going to be scratching the surface this morning. So if there's anything else you want, then please, you can watch it again on the recording, or you can contact us directly, of course. So starting off with, why move to low GWP? Well, of course, the simple answer is legislation. Over the last 30 years, we've had lots of legislation in this industry pushing us to more environmentally acceptable refrigerants. And now we're on to the situation where we need to move on GWP, global warming potential. Of course, in Great Britain and Europe, we're working to the F-gas phase down. And everyone should be familiar with this step down by percentage shown here from 2015 to 2030. But after that, we then have the Kigali Amendment, which most of the EU and UK have ratified and will be adopting. So there is further reduction required after that to meet that. And also, of course, there are some bans which have been put in place. Just a few of the more recent ones and ones to come are shown on this chart here, involving use of products less than 2,500 for new equipment. And going next year, we're looking at more bans with even stricter for retail and hermetic systems. And we have our first audience question, which was submitted during the registration. When is the 2,500 GWP limit going to be decreased for stationary systems and condensing units? And what will it be? Well, we'd all like to know that, quite honestly. Right now, the review process is going on in the UK and in Europe. And that process is indicating that there's going to be changes with things like this, but we don't know what they are yet. The EU have indicated that the first proposals will not be seen until the spring of next year, so we really have to wait until then. But I think it's a reasonable assumption to think that this is going to happen. So that phase down gives us an idea of where we need to get to, but it doesn't really help us in terms of what refrigerants we need to be looking at and how low is low GWP. So this chart is essentially the same chart using data which is available from within the EU on quantities of refrigerant used. What we can do is come up with a rough average of where we expect we should be in terms of GWP come each of the step downs. And you can see it on this chart. And you can also see where each of the refrigerants fit within that scheme. So we're currently 2021, nearly into 2022, and we're around that 900. We should be around that 900 average. So anything significantly above that is obviously at risk at some point when the quota starts to bite. And as we go to further phase down, step downs, what you'll see is we really need to be moving towards these much lower GWP refrigerants. Not all of them are shown on the chart there, some of them are in the table. But we really need to be moving towards that average of 400 and eventually 300 when Kigali is implemented as well. And remembering this is an average. It doesn't have to be 300 or below, as long as the average, so we can use some higher GWP products, as long as there are other ones to offset it. But what can be said for sure is it's very unlikely anything with a high GWP will be sustainable in any large quantities going forward, because that would just take the average above there and we won't have enough quota. So we have another audience question at this point. Are there any low GWP refrigerants which are non-flammable? Will A2L refrigerants become the trend for future refrigerants? Well, you can already see on the table there's carbon dioxide. That's a non-flammable low GWP refrigerant, but there are a few others. 515B, for example, is a non-flammable refrigerant. It's a 134A type refrigerant, and we'll talk about that a little bit later as well. We've also got the low pressure refrigerants, 1336, 1233ZD, and maybe a few others which come along for very specialist niche applications. But these are the ones that they're really for low pressure systems. You may have seen just this morning on one of the media outlets, 1233ZD is being looked at for a high temperature heat pump system. So this is the type of thing where these products are going to be used. The mainstream refrigeration, air conditioning are going to be using the other products which tend to be A2L. So we've seen what we consider to be a low GWP refrigerant, but why move to low GWP now? Well, this chart shows you an excerpt from the OCA research report, which is sent to the EU, looking at refrigerant prices across Europe. This is for Q1 in 2021. And you can see back in 2017-18 that peak which we all experienced due to the tightening in the quota, but then various things happened, illegal imports, there was some stockpiling going on. There's lots of various reasons, lots of theories as to why the prices have come down since then. And you might say, well, with the prices on this current trajectory, why should we bother to change? And the reason, of course, is the phase down. We're already probably not up to where we are with the phase down. I would challenge anyone out there using refrigerants to take stock of the refrigerants you use, work out what the average GWP of them is. If it's well above 900, you need to be looking at how you can change that, because at some point that quota will bite and we'll be back in that situation we were in 2017-18 with the higher GWP products. Again, another audience question. With UK quota restrictions close to biting, why have many users seemingly stopped work on low GWP options? Well, one of the reasons is what you're looking at now. The prices have come down. It would appear on the face of it that there's maybe not a problem out there, but this is very much a false sense of security. And at some point, we will see that bite of the quota, and we will see the raise in price like we did in 2017 again. So you can carry on using the products that you're using today, higher GWP products, but they're not sustainable going into the future. So hopefully, very soon, we had the perfect storm of COVID and Brexit as well happening in the UK. So all these things had an impact. So hopefully that will now turn around and people will start to move again. So that's all very well. We still haven't addressed why people should move to low GWP now. We've looked at the reasons why it haven't, but why should they? Well, I'm sure many of you played this game in the past, Top Trumps, certainly I did. So let's do a bit of refrigerant Top Trumps. Looking at the various parameters here, so global warming potential, obviously the replacements are very low to very low. That's a necessity of the phase down. You need sustainability. If it's a higher GWP, if it's well above those average GWPs, then sustainability and price stability is going to be poor. Energy efficiency is really important. Going forward, that translates into emissions, that translates into running costs, So it's really important to get good energy efficiency from your systems. And when we look at the across the line there, you can see I've put for A3s moderate. What I'm not talking about individual systems. I'm talking about larger condensing unit systems where you probably need to use a secondary system, and that impacts on energy efficiency. And CO2, that generally, fundamentally has a poor energy efficiency. You can do things to the design to improve the energy efficiency, but fundamentally, thermodynamically, it has a poor energy efficiency. Refrigerant charge is obviously an issue when we come to things like flammable refrigerants, and we'll cover that in more detail as we go through. And total cost of ownership. A lot of the time, everyone is looking at the cost of installation, the cost of how much it's going to cost me to put this system in, and ignore the fact that that system may be cheap to put in, but it may cost you a lot of money over the lifetime of that system. So it's really important we try and, as an industry, try and look more at total cost of ownership rather than just cost of installation. It's a much better indicator of value for money. So these are all good reasons why you might want to move to a low GWP. But for me, there's one more, which is really, really important. Retrofit options. In the past, when we've used high GWP, for example, 448, when we needed to move away from 448, we retrofitted the system to 448 or 449A. And that was relatively easy, relatively straightforward. Going forward, if you're putting in a 448A, 449A system today, and you want it to see through its lifetime, what are you going to do when the phase down bites, and it's either very expensive or very difficult to get hold of those products because there is no retrofit option? And this is really important. So any system you're putting in today, you want to see it through to its normal lifetime, then you need to put in a refrigerant which has sustainability and will take it through to the end of that lifetime. And that will not be current moderate GWP products. So let's take a look at which products you might be able to use in which application. This is a very quick overview of where we are on this. So starting with self-contained or plug-in hermetic systems. And for the purpose of this, hermetic, we mean all permanent joints in the system. So there are some standards and regulations applying to this. From an F-gas point of view, from the 1st of January next year, all refrigerants in new equipment will have to be less than 150 in this type of equipment. And in terms of standards, the latest version of IEC 60335-2-89 allows a maximum of 500 grams of A3 refrigerant or 1.2 kilograms of A2L refrigerant. Now, it's difficult to compare these. They're going in lots of different types of equipment. So what I've done is taken some theoretical cycle calculations using the RefProp software, and you can see that the conditions which have been used there to do the calculation. Here's a capacity calculation, gives you an idea of the relative capacities. Because we're talking new equipment here, it doesn't really matter that it's a lower capacity refrigerant like propane, for example, compared to 448, because you can use a bigger compressor. You can design for that capacity load. So the capacity difference is just there to show you how they do compare to each other, but it's not going to be an issue if there's a lower capacity, although there may be some limitations in this type of equipment. For example, space can be of a premium, so a much, much larger compressor could be an issue. But certainly for the examples we're given here, none of these would be a problem. But what's really important, as I said earlier, is energy efficiency. So when we look at the COP of these refrigerants, we can see they're all better than 448, which is what may have been used in the past. And we can see here that why, in many cases for this type of equipment, hydrocarbons are used, because they are showing the highest energy efficiency, both at medium and low temperature, whether it be propane or propylene. But the other low GWP options, the 454C, 455A, they both show energy efficiency gains over 448 as well. So they're both good options in any situations where flammable, the A3 flammable refrigerants may not be accepted. So also, some of the systems may have used 134A in the past. For domestic applications, isobutane was used in these applications. but in many commercial applications, as you can see on the chart, it's a very low capacity compared to 134A, and the extra size in the compressor is going to be difficult. As I said, size is often a premium in this type of application. We can also see that there are other A2Ls. We have 1234ZE. That has a lower capacity than 134A, but I said in new equipment you can use a larger compressor, and that is also a possibility as used. But many of these systems, again, have gone to propane in medium temperature and low temperature. When we look at the COPs, the energy efficiency, here, maybe a surprise to some people, we'll see isobutane certainly had a higher energy efficiency than 134A, but as we already said, it's not really used in commercial equipment because of the much lower capacity. But 1234ZE actually has an equivalent energy efficiency to 134A, and actually better than propane. So 1234ZE may be an option for medium temperature. It's not really an option for low temperature. The boiling point means we'll be going into a vacuum to operate in low temperature applications. So for that, certainly propane is looking at a good option. So moving on to single compressor non-retail, commercial, and I emphasize non-retail because there are different rules for retail, which we'll get onto very shortly. Standards and regulations. F-gas again, of course. As far as this category is concerned, this application, at the moment, it's just a 2,500 limit, and that's been in place since January 2020. We also have EN378 coming into play with this type of equipment, so charge restrictions will apply depending on the safety class and many other aspects, and we'll look into that in a moment. And also we have the pressure equipment regulation, PED, which again has to be taken into account, but PED applies to all refrigeration systems. It has done since 2015, but with the flammable element, there may be some more rigorous checks or certifications or even qualifications, engineer qualifications, which are required. So EN378, as I said, it applies to all refrigerants, not just A2Ls or any flammables. And some people may be surprised to learn, it's quite often overlooked, that all refrigerants do have charge size restrictions. You can see here on this chart, we have 3 A1 refrigerants, 410A, 134A, and carbon dioxide. And you can see there's quite a big range already in the charge size restrictions allowed under EN378. So it doesn't just apply to A2Ls, it's just with the flammability, quite often the charge restrictions are a little more severe in some cases. So let's take a look at the flammables. Right at the bottom there, we've got propane. This is the allowable charge of propane under EN378. It gets a lot more complicated with the A2Ls. There are a number of different scenarios we can look at, depending on the room volume, depending on the number of additional protective measures you might be taking. But essentially, if the room volume is large enough, you can go up to easily up to the levels of 11 to 16 kilograms without any additional protective measures. But then for systems where the refrigeration system is outside, so a typical condensing unit, and then you would see you can go up to much higher levels, and with some additional protective measures, you can go right up to, depending on the refrigerant, you can go right up to 84 kilograms of refrigerant as well. So there's a big range of potential charge sizes which can be used depending on the conditions. And I'm not going to go into the details of EN378 today. If anyone wants to do that, you can by all means contact me at a later date. Another audience question. What safety measures are required for a small store with a refrigeration load approximately 15 kilowatts with a floor area of 160 meters square? Well, first thing I would say is the EN378 for refrigeration works on room volume. So the floor area and the amount of refrigerant allowed will depend on the ceiling height. I've got 2 examples here. I've got on the chart 3-meter ceiling and 4-meter ceiling. Where that line crosses the various lines for the different refrigerants, that will be the maximum charge quantity which can be used. And you can see, you know, in the top case, you can use with 455A, you can use 84 kilograms, so that's the maximum you'd be able to use there, and around 57 kilograms with 454C, which would easily cover a 15 kilowatt system in a size this size. It would be well below those levels. In fact, probably well below the QL and V levels on there. I've put carbon dioxide on there as well, because although it's an A1, as I said earlier, there are still charge size restrictions, so they have to be taken into account even with carbon dioxide. Another question, do we have any widgets or Excel-based tools for EN378 ventilation sizing in enclosed plant rooms, special machinery rooms? Unfortunately, we don't have ventilation calculations. We do have, you can see on the left-hand side of the chart, we do have a web-based EN378 charge size calculator. We call it an A2L charge size calculator, but there are all the refrigerants are in there, basically all the A1s. You can do the charge size calculations for just about any refrigerant using that. If you need any help on that, by all means, contact us and we can help you. Maybe the ventilation one is something we should look at in the future. The next thing to take into consideration when using moving from an A1 to an A2L or A3 refrigerant is, of course, the pressure equipment regulation. Under this, the A1 refrigerants have been in the fluid group 2, but the A2Ls, with the exception of 1234ZE and the A3s, are all in fluid group 1. And this has quite a big effect in terms of which category the system may fall into, and it will change categories at much lower volume. The table there is for a vessel on the high pressure side. You can see where it changes. If we take an example, a system with a 10-liter liquid receiver on the high pressure side with 44A or 449A, that would be category 2. But with 454A, 454C, 455A, and carbon dioxide, that would move up to category 3. 1234YF, if you went to a lower pressure A2L, then that would remain at category 2. And if you used 1234ZE or 515B, then that would actually go down to category 1 because of the lower pressure. So, and also they're considered group 2 refrigerants under PED. So you can see there's a big difference there, and this is one of the main reasons why you won't be able to use an A2L in an A1 system as a retrofit option, because making this change of category on a system in place is going to be very, very difficult to say the least. So we should do the comparison as we did with the hermetic systems. These are theoretical calculations. I've not included hydrocarbons on this because in most cases for this type of application, we're going to be outside of the charge size allowed under the EN378. So we're just looking at the A2Ls as alternatives here. There are no A1 low GWP options for this. So we are with the A2Ls for this application. You can see there for medium temp and low temperature capacity comparison. When we move on to the COP, energy efficiency, again, we can see all the options, all the low GWP options actually have a better energy efficiency than 448. And potentially over the lifetime of the equipment, that offers a payback opportunity for any additional safety measures such as leak detection, which may need to be included when using an A2L in many applications. To compare it with carbon dioxide, it's quite a tricky one because obviously the technology is quite different, the systems are quite different. But what I've done is done some, again, theoretical calculations based on a system where you have a carbon dioxide, a simple carbon dioxide booster system with low temperature 4 kilowatts, 10 kilowatts, medium temperature, comparing that to two individual systems with an A2L refrigerant at medium temperature and low temperature. At the design condition, you can see there's a very significant difference in the COP, the energy efficiency. And this is even using the same compressor isentropic efficiencies for both the carbon dioxide and the A2Ls, which is not normally the case. Normally, you would see a drop-off in isentropic efficiency in the CO2 system, but I've applied the same to both. So that's it, the design condition. If we look at a more typical operating condition, especially for the UK, 15 degrees ambient, then we can see, although the carbon dioxide system COP has gone up, also the other refrigerants have gone up as well to a greater extent. So we're actually seeing that gap widen between them. So you can see in any situation where you're looking at a low GWP option, you need to evaluate, can you use, what refrigerants can you use, how do they perform, and how this obviously translates energy efficiency, as I said earlier, translates into emissions, but it also translates into running costs as well. So it's really important to do these to make sure you don't just base any decisions on refrigerant GWP. There may be some people out there using 134A type condensing systems. In this case, we have some other options. 1234YF is an option. 1234ZE is also an option, but I've included 515B, which has a very, very similar performance to ZE, but it's A1 classified. So although you would need a larger compressor to get the capacity, medium temp conditions, you have got the A1 possibility with that. And we look at the energy efficiencies, and you can see that they're all very close, the 1234YF, and I put 454C in there. That may be an option. It's got a much higher capacity, obviously, but it may be an option worth considering, although the efficiency is slightly lower than 134A, whereas the 515B has an equivalent efficiency to 134A. Multi-compressor retail refrigeration systems. So under the F-gas, as of January the 1st next year, so just a couple of months away now, new refrigeration equipment with a cooling capacity of 40 kilowatts or greater must use a refrigerant with a GWP less than 150. So this is going to be a big change for that application, obviously. The N378, as with the condensing units, also applies, and of course pressure equipment regulation also applies in this application as well. In all applications where so this chart has come from something that was published a couple of years ago. It was done by an independent consultant, Wave Refrigeration. And what it really shows is maps out what technologies, because there are many different choices of technology you can use in retail refrigeration. So what this does is map out which ones are giving you the lowest emissions at the lowest life cycle cost. So anything to the bottom left-hand corner is more favorable. Anything towards the right top-hand corner is less favorable. And you can see very clearly from this study that the lower GWP options like the A3s and CO2, once you put them into the system and you take into account all the other aspects of that, then we're seeing that the total emissions, including energy consumption, are not maybe as favorable as everyone might have expected. And the A2Ls are coming out with a very good situation. So the main message from this is low GWP refrigerant does not necessarily equal the lowest total emissions. And lowest total emissions are not necessarily going to be the highest life cycle costs. You can get low emissions and low life cycle costs as an option. And it's really important to evaluate each application to determine the lowest total emissions and best value for money that technology is going to give you. This is a case for particular supermarkets, but in other applications, this may not be the case, and maybe the other technologies are better for those applications. Rather than go through theoretical cycle calculations, which would look almost the same as we just looked at for the condensing units, I thought we'd give some case studies which have been published already. This one, Central England Co-op, Langley Park in Derbyshire in the UK. This was installed back in September 2019, so it's been running for 2 years. As you can see from the information there, it's running extremely well and showing energy savings over similar stores which were installed before that, leading to Kevin Collins, the head of facilities there, to state that it meets all the criteria, 454C meets all the criteria, and it will be rolled out in the future stores. And I believe that's exactly what's been happening since then. This example, slightly bigger supermarket. This one's in Spain, Catalonia, with 455A. You can see the details of the system there. And again, the comments back from the installation engineers were that the system was very similar in terms of there were some additional safety measures which had to take, leak detection and such like. But overall, it was very similar to installing an A1 refrigerant system. And the end user also was very happy with the way it was working and was looking to roll this out as a future option for their stores as well. Final example, you may have seen this, been well publicized over the last couple of years at Asda. With Asda, they chose to go the 455A route. If you remember back at the beginning, 455A actually gives a higher capacity than 444A, so they're getting a bit more bang for their buck, if you like. But because 454A is above 150 GWP, so 238, they systems are less than 40 kilowatts. So Asda had already moved to a modular system years before this, and this was now put them in a great position that they can easily change to the A2L 454A in this system. And they've shown energy savings, and from their own internal studies, they've concluded that lower capital and maintenance costs than CO2 systems. And all new Asda stores, all new installations are now either A2L ready or will be installed on an A2L. And next year, obviously, from next year on, will be on A2Ls. Finally, industrial refrigeration. We have an extra candidate in industrial refrigeration. Of course, ammonia is widely used already in industrial refrigeration and is the lowest GWP. It's the only refrigerant with a GWP of 0. So that is definitely in the mix. But it also, because of the wide range of applications and situations in industrial refrigeration, is also, almost all the refrigerants can be used. So ammonia is widely used, especially in larger systems. Where ammonia cannot be used in larger systems, you're seeing carbon dioxide taking up some position in that situation. But also A2Ls, the two pictures on the left-hand side there are warehouses, one in France, one in the UK, where A2Ls have been used for refrigerant. But also A3s could be used in some situations as well, maybe in a secondary loop or other situations. So basically what you have to do, and this goes for all the applications, but you have to check, is it sustainable? What's the energy efficiency? Look at system complexity, total life cycle costs, total emissions, ease of maintenance, reliability, safety. Evaluate all of these and see which makes the most sense for your application. And industrial refrigeration, like I said, because of the very wide range of different applications, you'll have to do this to decide what is the best option going forward. So what do I need to use to do the A2Ls? Well, we've covered a lot of what you actually need to do with the A2Ls. I'm not going to go into huge detail here because we don't have a great deal of time. We could spend the whole 45 minutes just on this subject alone. But just to skim over it again, EN378. EN378 covers many aspects of system safety. It's not just charge size. But when we come to flammability, charge size becomes definitely an important factor, and there are guidance within the standard to help you design systems and use charge sizes which will prevent flammable atmospheres from occurring. Pressure equipment regulation, we've covered that as well. It's really important that you comply with this. It is the law. It's a regulation. We have to comply with it. And if you're looking at existing equipment, please be very aware of the limitations you're going to face under pressure equipment regulation. This is why A2Ls and A3s are really new equipment refrigerants, not retrofit options. If you comply with the EN378 and you comply with the pressure equipment regulation, that doesn't remove the need for you to still do a risk assessment. They form part of the risk assessment. All air conditioning, refrigeration, heat pump systems require a risk assessment. And as I've already mentioned, since 2015, DSIR, Dangerous Substances, Explosive Atmospheres Regulations, applies to all gases under pressure, which is pretty much all refrigeration systems. There may be some, if you comply with the EN378 and you prevent flammable atmospheres from occurring, that makes things easier under DESIR. But if you cannot prevent flammable atmosphere from occurring, then risk assessments must be performed, as guided through with the DESIR regulation and using the principles of EN 60079. There are quite a lot of guidance available. The Institute of Refrigeration published a number of documents to help guide you on what does need to be done. And in the very near future, there will be a feature document published as well, helping on using applying EN 378 and the pressure equipment regulation to A2L. So keep an eye out for that in the press. So in summary, legislation is driving the industry to low GWP refrigerants. Stay ahead of the curve. Don't wait until the next quota crunch bites. Don't wait for that 2017 situation to happen again before you do something, because you will find yourself in a lot of difficulty. Do it before, even if it appears you don't need to. A wide range of low GWP refrigerants are already available, and equipment, not an absolute full range, but a very wide range of equipment is now available for use with these refrigerants. There are no easy retrofits to low GWP options. If you install an A1 high or moderate GWP refrigerant today, that is the refrigerant you're going to have to keep using to the end of the life of that equipment. Lowest GWP does not necessarily equal lowest total emissions. Do your homework. Evaluate the system. We can help you with that. Talk to us, and we can help you to do that and make the decision based on all the information, not just based on the GWP of the refrigerant. Different applications will be suited to different low GWP options. There's no two ways about that. A2L is not the answer to everything. CO2 is not the answer to everything. Hydrocarbon is not the answer to everything. So you need to evaluate energy efficiency, total life cycle costs, emissions, and all these things to really determine what might be the best option for you going forward. And of course, the team at Clean Life are here ready to help you to navigate the maze of moving forward. We can do things like all the performance analysis you've seen. We can do that for specific applications. We can help you with charge size calculations. We can help with the pressure equipment regulation calculations if that's what you need, and also all sorts of data and other advice as well. So just please do come and talk to us. Anyone visiting the Hampshire Refrigeration Society exhibition tomorrow, we'll be there. Come and have a chat.
Thanks, Neil.
And I think that's me. I'll hand you back to Mel.
Okay. So now it's time to take some questions from the audience. Let's have a look. So first question, in fact, there's two questions kind of linked. So what is the timeline for 410A conversion? And the other question is replacement for 410A and the future of VRF regarding required kilogram tons of refrigerant. So over to you.
Right. I haven't mentioned air conditioning in this. I apologize to anyone who tuned in to hear about air conditioning. The main reason for that is this is pretty much led by the manufacturers. The manufacturers decide what refrigerant's going in there, and they supply the equipment. Obviously, R32 is taking over a lot of our 410A equipment. In terms of the timeline, the chart right back at the beginning, you can see 410A is right at the top of the pile right now in terms of GWP. When will that become a problem? When the quota bites. If and that's going to be sooner rather than later. So I know there's still limitations on some equipment, and some equipment is only available with 410A, but if you have an option to use anything other than 410A, I would strongly recommend doing that already. In terms of the replacement 410A future VRF, there's a lot of work going on in that. You need to keep up to date with the manufacturers. In terms of retrofitting, there is a product which is available, which is being tested at the moment, and I would call it in the moderate GWP range. There is nothing in the very low to very low GWP range which can be used to replace 410A. But where possible, try to avoid it, and if you can't avoid it, well, just be aware that there may be some constraints later in the lifetime of that equipment.
All right, lovely, great, thanks. Next question. Which is the maximum allowable amount of A2L refrigerant in a system for safety reasons?
Okay, so if you remember back to the quite complicated chart with all the lines on it for the EN 378, there's a lot of depends comes in this. It's refrigerant dependent, it's situation dependent, it's application dependent, but you can go up to 84 kilograms as a maximum. Other refrigerants will be lower than that. But also, whether you have it with additional protective measures or without additional protective measures, that will all come into it. So the maximum number is 84 for 455A, but you can. It really depends on the situation. So you really need to use something like the CleanRelife A2L tool, or speak to ourselves and we'll help you to determine what's good for your application.
Okay, got another one here. Are any of the new low GWP refrigerants suitable for rooms at minus 42 degrees C?
So I once, going back a bit, showing my age here, but I once saw an R12 system operating at minus 80. Now, nobody in the right mind would probably do that, but this particular company did. So when you say, is there any refrigerant can use it minus 42? Well, the answer is yes. There are many other limitations that may come into play, but 454A is the highest GWP, highest capacity low GWP refrigerant. It does have higher discharge temperatures, so there will be some difficulties there, but it will come down to the design of the system. Yes, you can do it with 454A. You could do it with 454C, 455A if you really wanted to. But it comes down to the design of the system. It won't be a straight swap. You won't be able to take the existing design, make it an A2L compliant, and then put the A2L and expect to get the same performance. You will have to design the system specifically to get that performance at those temperatures. But it is a bit of a challenge. But I have seen systems running at very low temperatures with other refrigerants, which shouldn't really be operating it there. So it is possible.
Okay. All right, great. Thanks, Neil. Next question. Why move to A2L refrigerants instead of A1 refrigerants that have lower flammability issues?
So as you saw in the chart, all the A1 refrigerants, we have to split it a little bit. The higher capacity refrigerants, all the A1 refrigerants have moderate to high GWP. And although that might seem okay at the moment, as soon as the quota crunch occurs and we see that the need to use lower GWP, those products will, in terms of price and availability, become somewhat unreliable. So you need to be looking at low GWP, and for the higher capacity products, low GWP basically means either A2L or A3. If you're looking to replace 134A, there is the 515B in there, which you could use, which is an A1 and low GWP. But that's really the only A1 refrigerant which is there. So moving to lower GWP, you're looking at either, you could look at CO2, but we've seen the energy situation there, so you need to make sure it is the best option if that's what you're going to do. And many of the people who've used the A2L refrigerants, there's a bit of a learning curve at the beginning to make sure you cover all the bases, make sure you do all the things you need to be doing to be compliant with standards and regulations. But once they've done that and gone through that, they're basically telling us it's pretty much the same as using an A1. There's not that much difference, but you do need to make sure you cover all those basis in terms of safety. But once you've done that, it's not that big a deal. So it's not something that people should really be frightened of. Yes, you have to learn, you have to put some extra effort in at the beginning, but it's not something to really be scared of.
Okay, good point. Another one that's come in, with the recent high-level prosecutions in the UK and 1 million fine for breaking quota rules, is this a sign that Great Britain F-gas means business?
Well, we certainly hope so. Obviously, we're not in a position to say that this is going to, we're not putting the fines on, as it were. But yes, absolutely, it's a great sign that that's happening. Something which the whole industry has wanted for some time, to see that the regulations are actually being policed, and this is a great sign that that's going on. And if this can, well, the end result of this will be that the quota will start to bite, of course, because there will be less product on the market coming in from dodgy sources, should we say, and then we will be into this situation where what's only be available if people have the quota. And if we're, as I said earlier, I challenge everyone, work out what your average GWP is. If you're well above 900, you should be worried, because that 2017 peak we saw is going to happen again, and it'll catch us all by surprise again, because none of us have a overview of everything in the marketplace. So, be prepared. Don't wait. Get ahead of that curve.
I've got a lot of questions still coming in, so I'm just going to try and fit a few more in. So, next one is
just to assure everyone that we will answer all the questions, and we'll publish them on the website later.
Yeah, absolutely. Is REACH a threat for A2L?
So what I think this question is referring to is there's been a lot of media attention or reporting of what's happening in the EU, and 5 of the member states in the EEC have put forward a proposal to basically ban what they call PFAS. There's a lot of work going on within the industry to work with governments and the bodies involved with this, because this PFAS umbrella is covering a huge amount of products. Some of them are very unpleasant things, but some, like the refrigerants, are already covered by legislation and are already being dealt with. And so it's really important that we try to separate out the refrigerants from the rest of the PFAS. And everyone has a part to play with that. There's, I think it's still open for about another week or so. There's a call for evidence going on in Europe, and anybody who uses fluorocarbon refrigerants basically should be putting in their view on whether or not they think there's a need to use them. And I think if we were without fluorocarbon refrigerants going forward, then the whole industry would be in a big problem. So it's really important that everyone has a voice on this. Get in touch with your local, with your industry associations, or be proactive and go further and do it yourself, and make sure that your views are known, that this industry is taking care of these issues in its own, and it doesn't need to be part of this bigger umbrella action which is going on.
Okay. So last one. Will insurance companies recognise an A2L instead of classifying everything as flammable?
So this is always a tricky one. First of all, you should always make sure that the insurance company knows that it's an A2L going into the system. That's really important. Don't try and hide that fact. As you've seen, there are a number of cases where A2Ls are being used, which I've shown even in supermarkets, in larger systems. Although insurance companies are not experts in refrigeration, they are experts in risk management. If you can demonstrate to them that you've done the risk assessment, you've complied with all the regulations to make sure that this system is safe, then the evidence is that insurance companies will accept that. But as things stand, most of the regulations do not differentiate between an A2L and an A3 flammable. So that is the kind of starting point that everyone will come from. But as I said, if you can demonstrate that you've complied with the N378 or any other necessary regulations and standards which you need for your application to use a flammable, then you can demonstrate that the risk is negligible, and insurance companies should be able to understand that and accept it.
That's great, thank you. Okay, well, I'm just going to answer one very quick question. Somebody just asked if the slides will be available afterwards. So just to confirm, a recording of today's presentation will be sent over to everyone that's registered, and we'll also upload it to our ClimaLife YouTube channel and also to our website in the next few days. But obviously, if there's anything specific you want in the meantime, do get in touch. And all the questions that we haven't been able to cover off this morning, we will answer them all in the next few days and publish those for everybody to see. So if you've raised a question, we haven't answered it, then apologies, but we will follow it up afterwards. So thanks to everyone that submitted questions today in advance, sorry. As mentioned earlier, all the questions raised will be published on our website. To wrap up, I'd like to say thanks to Neil for sharing his knowledge and expertise with you all today, and especially to thank you all for joining us. We really hope you found it interesting and useful. There'll be a short feedback survey that pops up on your screen as we close the session. So if you can, please take a few seconds to give us some feedback, as it will help us to plan and improve our future webinars. Don't forget, the ClimaLife team collectively have a wealth of technical expertise and knowledge, so please do contact us if you need help or advice on an upcoming project. Until next time, stay safe, and we look forward to seeing you soon.